Introduction to sequences and series. Sequences are lists of numbers, both finite and infinite, that follow a certain pattern. Here on the top left, we can see a sequence that goes up by 2. Each term in the sequence is added by 2 to the one prior to it. The one below that, each term is being multiplied by 2, and that's the rule of that sequence. The sequence on the top right is an infinite sequence. You can tell by the 3 or 4 dots to the right. That signifies that it goes on forever. This sequence, each term is being added by 5 to get the term after it. The sequence below that, each term is being multiplied by 3 to get the next term. So just to reiterate, a sequence is a list of numbers with a rule or a pattern that it follows. Series is the sum of all the terms in a sequence. So with our previous sequences from the previous slide, we can see that when you add up all the terms, you get 20, and on the next one, when you add up all the terms, you get 15. So let's talk about sequences versus series. Here we have an example of logs stacked in a pattern. In the bottom row, we have 7 logs. Then 6, then 5, then 4, and all the way to the top where we get 1. These logs, each row, we are removing 1 log, and it's our pattern. So we get 7, 6, 5, 4, 3, 2, 1. That is the sequence of this arrangement. And the series is the addition of each row. So what we're going to learn in this chapter are patterns and special ways that we can make this faster instead of just adding up individual rows. So what kind of applications of sequences and series will we see in the future? We'll talk about finance, construction, population models, patterns found in nature, and how musical instruments are created. What kind of real-life questions can sequences and series help me answer? Questions about mortgage, patterns that you see in nature. You can also see predictions about the growth of plants, how synthesizers work. We can also ask really big questions like how many pennies are there going to be stacked in this pyramid? You can see that this is a tedious task if we're just going to simply count. So we'll see in this chapter different models that we can do and different equations that we can apply to a pattern so that we can make this a quicker process. So you'll be able to answer this in a matter of minutes, how many pennies are in this pyramid. The goals for the lesson are to identify patterns and differentiate between types of sequences, explain how a sequence can be expressed as a function, derive the structure of any arithmetic or geometric series, find the nth term of a series, and apply this knowledge to real-life applications.